My crystals have grown a little bit since the last video, but not too much, and I think the increase in growth was mostly due to the solvent evaporating, so the crystals had more opportunity to grow larger, mostly due to the removal of the Kim wipe from the top of the container, which I mentioned in the last video. To grow one large alum crystal from the crystals that we have made, you could take one of the crystals out of the solution of crystals and discard the other ones and just use the biggest one that looks the best, and then use either like a piece of like string or something like that and tie that around the crystal, and then also tie the string to like a popsicle stick or a pencil, and then lay the pencil over the top of the jar so that the crystal like dangles in the middle of the jar, and then it should grow to be a bigger, pure crystal. D-spacing is significant because it allows you to figure out the space between the planes of a certain crystal, and then from that you can figure out where all the atoms are, which would allow you to reconstruct the crystal. And also, using Bragg's law, it gives you information about the wavelength, which you can use to determine constructive or destructive interference, and the diffraction grating, which allows you to figure out how light is reflected in the crystal and how it is diffracted. To calculate the D-spacing, you first look at the most intense peak on the graph that was given on Lab Archives, and then you can discern from the graph that 2 theta is approximately 20 degrees and the intensity is approximately 1500, and then the wavelength given is 0.15418 nanometers. And then using that information you can plug it into Bragg's law, which is the equation 2d sine theta equals n lambda. So then you can say 2d sine of 10 degrees, since 2 theta is 20 degrees, so theta is 10, equals 1500, which is the intensity, and the same as n, times the wavelength, which is 0.15418 times 10 to the negative 9th meters. And then plugging all those numbers in and solving for d, you get that the D spacing is approximately 668.6 nanometers.